Hello and welcome to another session in physics. In this session we'll be looking at the topic Goldleaf electroscope and its uses, and we'll look at lighting and lighting conductors. But before that, let us review the previous lesson. Welcome back. At this point, let's look at what a Goldleaf electroscope is all about. As you can see from the slide here, the Goldleaf electroscope is an instrument that we use for the testing of the presence of positive and negative charges. As you can see from the diagram here, the Goldleaf electroscope consists of a number of components. It contains what we call a thin gold leaf, such as the one you can see here. That's the spot where the gold leaf is located. Or they use aluminium sometimes. They use aluminium leaf sometimes instead of gold leaf. Alright, so this leaf is attached. Now the essence of this leaf is to either diverge or converge when it senses the presence of either a positive or a negative charge. So it reacts according to the kind of charge that is brought very close to this brass cap. You notice very well, this is a brass cap or a brass disc, and this brass cap is insulated. It is insulated from the casing. The reason why it is insulated is so that somebody does not mistakenly touch it and then all the charges that have been gathered by it becomes dissipated. You know, the human body, like we said time without number, we've said countless times already, the human body is a very good conductor of electricity. So assuming that this brass cap was able to retain and capture a charge and somebody touches the casing, what happens is that this charge is going to change and it's not going to give an accurate result. So because of that, it is insulated from the metal case, such that when you touch this metal case, it has nothing to do with what is going on at the brass cap. Alright, it's also important for you to note that the leaf, this aluminium leaf or the gold leaf we talked about, is protected from outside influences such as drought. It is protected from drought by enclosing it in an earthed metal case that has glass windows. So generally, the gold leaf can also be used to test the conducting properties of materials. So we use them basically to test for the presence of positive charges and negative charges. That is the basic function of a gold leaf electroscope. You can see the diagram here, what it looks like in reality. Here you look at the gold leaf or the aluminium leaf, and then you look at the metal casing, look at the glass that has been insulated, and then you look at the base stand where it is kept. The surface on which it is kept, it is also properly protected so that charges that it has gathered does not get dissipated. Like we've been saying earlier, the electroscope is used to test whether a material possesses a charge or not. Now, if a material possesses a charge, that material is said to be a conductor. But if that material does not possess a charge, it is said to be an insulator, because materials that allow electric charges to pass through them are conductors, and materials that do not allow electric charges to pass through them are said to be insulators. So all you have to do is just to get the material you want to test for the presence of a charge in it and use it to touch the brass cap of the gold leaf electroscope. You would notice that the leaf will either collapse rapidly, which means that the material is a very good conductor. The rapid collapse simply means that the charges were able to escape easily. So when charges escape easily when they are brought in contact with another body that is also a conductor, it means that that body that possessed the charges is a very good conductor. But if the leaf shows a slow collapse, it means that the body is a good conductor, is a conductor, quite alright, but it is a poor conductor due to the slow collapse. Look at it as the principle of a battery. When you put a battery inside a torchlight, you would come to realize that if the battery is very strong, if it is still very good, very much alive, if we use it in a layman's term, the torchlight is going to give you bright lighting. But if the battery is dying, so to speak, if the battery is almost like it has almost exhausted its life or life cycle, you would notice that the torchlight would give you a very dim or faint lighting. Then on the electroscope, if there is no collapse at all, it simply means that that material is an insulator. Another use of the Goldleaf electroscope is that, like we have said countless times already, it is used to test for whether charges are positive or negative. So how do we know exactly which charge it is, whether it is positive or whether it is negative? What is the sign? Now, if we get an unknown charge, let's say a charge is brought close to an electroscope and we don't know what that particular charge is, look at the leaf. If the leaf diverges more, when we say diverge, we mean spreading out. If it spreads out more, it means that the unknown charge is similar to the charge on the electroscope. So if the electroscope already has a negative charge on it and you brought an unknown charge, a body with an unknown charge close to the electroscope, and the electroscope proceeds to diverge more, as you can see in figure B here, it simply means that the charge on the electroscope and the unknown charge are basically the same. But if it does not diverge and it converges or diverges very, very slowly, seems to be closing up, it means that they are opposite charges. So possibly the electroscope is positive and the unknown charge is negative. Hence the reason for the slow divergence. Okay, so how do we charge an insulated body, a body that has been insulated? How do we charge it? Now, a neutral body that has been insulated can be charged using two basic methods. They are the contact method and the induction method. Sometimes we say there are three methods. Actually, we count charging by friction as a method of charging. So if you want to add that, but principally and officially we use two: contact method and induction, because friction somewhat also has to do with contact. So let's look at them extensively now. Now, about the contact method is achieved when we bring a charged object in contact with a body that is already charged. When we bring a charged object in contact with that body that we want to charge, that body we want to charge that possesses no charge, that is neutral, bring it in contact with a charged body. By so doing, the neutral body that has not been charged will acquire the same kind of charge as that on the object that has been charged. So for example, let's say this body here is negatively charged. It has been charged negatively, contains electrons inside it, and this is a neutral body on an insulating stand. So we just bring this neutral body in contact, bring it very close to this one, and let both of them hug themselves, so to speak. Once they come in contact with each other, what happens is that that body is going to get negatively charged as well. So charges will flow from the charged body to the neutral body. If you're feeling cold and you hug someone that is feeling warm, what happens is that you start to feel warm too. That is charging by contact method. The second kind of charging is by induction. The method of charging by induction is simply a process of charging a neutral body by placing a charged body near it without any contact between the two of them. Take note of this terminology, without any contact. That's your keyword, without any contact. Now look at this. You know there's a big difference between this diagram and the one that we showed previously. The first one, there was contact here between two of them. They were basically touching each other, but this, there is a measure of distance between two of them. They are not touching each other at all. So by induction, this body was brought very close to this one that was negatively charged, and it ended up being positively charged. So that is how to charge a body by the induction method. Now let's see how this principle is used in lightning and lightning conductors. Like I already said some time ago, you know that the atmosphere is known to contain ions or charged particles, especially when the weather is damp. Now these ions or charged particles have been produced by radiation from the sun, especially cosmic radiation, which also enters our atmosphere from outer space. Because of that, and due to the disintegration of these charged particles and ionization taking place in the atmosphere, sometimes lightning can occur. What is lightning? Lightning is a sudden discharge or a neutralizing of electric charges, and it occurs when charges build up in the cloud. So when these charges build up and they are trying to neutralize each other, a sudden discharge results in what you can see in the diagram here, lightning, and it is usually accompanied by a sound which we know as thunder. But thunder appears to come after lightning must have happened. The reason for that is because sound waves travel late than light waves. So light travels faster than sound waves. So we tend to see the lightning first, and then after some time we hear the thunder. This principle is used in lightning conductors. Remember that we talked about the concentration of charges at the tip of a material which looked like this, and there were more charges here than there was at these other places. So lightning conductors are long metal strips that run from the spike end of the conductor to the top of the building. Now, what is the use of these lightning conductors? They are used to prevent the building from destruction when it has been struck by thunder or lightning. As you can see from the diagram here, you would notice that the lightning conductor is a long metal rod that has been installed or connected to the earth by means of a cable. The tip is pointed and it is very sharp. The reason why it is pointed at the top is because charges are concentrated there. So by this concentration of charges, it is able to gain what we call induced charges, which are opposite to that which is in the thundercloud. Remember, opposite charges repel each other, and similar charges, opposite charges please, attract each other, and similar charges repel each other. So if by induction this metal rod here gains opposite charges to that which is hovering in the atmosphere, let's say for instance in the atmosphere we have positive charges, and by induction opposite charges are created on the spike which is negative charges, you would note that they will be attracted to the tip of this lightning conductor, and what happens is that there will be a discharge. The molecules that have been created will now have to travel down this spike and then follow this long cable and down into the earth-fed mechanism. So this helps to discharge the cloud before a lightning flash occurs, and it helps to protect the building and the electric components that are. Thank you for joining us in this lesson. To refresh your memory, please click on the test that will appear on your screen.